Hello and welcome to LogRocket. Today I'm here with Jason Laster, who's the founder and CEO of Replay, and Mark Erikson, who's a senior front-end engineer at Replay and also a former LogRocket guest who you may remember from a previous conversation about Redux. How are you guys doing today?
Well,
doing pretty good.
Well, I'm really excited for this episode. Today, hoping to learn more about Replay, and then also I hear we have perhaps a demo, which will be something that will just be relevant to the YouTube version of this podcast. We can try to narrate it for the audio version and see if that works. But we'll put a link to the YouTube for the people that are listening just on audio as well. But yeah, maybe we could kick things off. Tell me about Replay. What is it? What does it do?
Yeah. So Replay is a time travel debugger. It makes it easy to record your website or node script now as well. Share it with anyone on your team so that they can debug it afterwards with familiar browser dev tools. Think the Elements panel, console, debugger, net monitor.
Got it. So it's primarily for web apps, correct?
Yes.
And so if I have, I have my web app running locally and I have a bug, is the idea that I can go into Replay, record it, and then have like an artifact that I send to someone else on my team who can reproduce that exact situation?
We're a lot like Loom, but with dev tools. And, we think of the world in terms of everyone's got Sentry running. They've got LogRocket. We use LogRocket. You see something went wrong. And then the question is, how do I reproduce it? So if you can go into Replay and reproduce it once, you can share that replay with anyone on your team on Slack, post the issue on Jira, and then devs can begin debugging without ever having to reproduce the problem.
Got it. And I think it might be helpful to frame this for our audience. Probably some, not all of our audience is familiar with LogRocket. So as a quick example or a quick understanding of how LogRocket works, essentially you have a web application that can be running locally or in production. LogRocket is capturing a replay of what's going on in the DOM. So we look at how the HTML and CSS changes over time. We capture that replay. We capture console logs. We capture a log of all the network requests that took place, a bunch of performance information. And we show that all to you. But what LogRocket doesn't do, and I think this is what we're going to get into with Replay, is actually replay the same JavaScript code. So the thing you couldn't do in LogRocket is look and see, what was this variable at this point in time. But with Replay, and I think that's something you do. So maybe tell me a bit more about kind of specifically like what you can do with Replay that, because maybe just to know, LogRocket is not competitive with Replay. We're primarily for production monitoring, whereas Replay allows you to do more because it sounds like primarily kind of for development processes and QA.
Yeah, where LogRocket's running as a JavaScript library in your app in production, gathering these replays, which is really, really useful to see what your users are doing, understand where your product is doing well, not doing well. And of course, when there's an exception, you can see that something went wrong. Go in and see what the user did before that. On the replay side, we're not a JavaScript library running in the page. We couldn't do what we're doing if we were. We're actually the browser. So we have a fork of Firefox, a fork of Chrome, we have a fork of Node. At the end of the day, these runtimes are recording what's going in and out of the runtime. So we capture all of the library calls that the browser makes. If the library wants to write to a file, we capture that. If it opens a socket, we capture that. All the necessary things needed to spin up that browser after the fact and replay it. And gosh, if a user in Japan on a really slow Windows computer is having an issue on some website and she records it with Replay, then a developer in San Francisco can view that replay and experience that exact session exactly as it ran in Japan. So the killer feature for Replay is you can open up the replay, find a file, just like you're in VS Code, like Command P, search for a file, that kind of thing, find a line of code that you want to add a print statement to. Add a print statement, and Replay is going to run through the recording really, really, really quickly, and then show all those logs in the console as if you'd always had that print statement there in the first place.
so taking a step back, like, JavaScript code is running, right? And like, if you have a line of code, 1 plus 1 equals, a variable a equals 1 plus 1, that's always the same. But then you have these sources of non-determinism. Like if you have a call to like, what is the current time? And you do something based on that, or you have a call to like, call some third-party API. Like there are things that are non-deterministic. So tell me a bit more about your approach to capturing those sorts of non-determinism and making sure the same thing happens in the replay that it did originally.
Yeah, that's such a great question. So it all starts with an HTML file. So the HTML file has some script tags, it has some image tags, it has some link tags. The browser gets the HTML file and begins fetching those assets. It's like, okay, I got to talk to the server. I've got to download this JavaScript file. Okay, the JavaScript file comes in. It has to parse that file and it has to execute that file. And as it executes, it sees like 1 plus 1. It has to evaluate that expression, that kind of thing. So that process of recording the socket connections and anything else that has to happen to load the JavaScript file and execute it, that's replay. So when we open up the replay later in the cloud and we're rerunning, the browser thinks it's talking to the internet to download that JavaScript file, but it's just reading from the recording. Actually, executing is deterministic. Every time you see a JavaScript file with 1 plus 1, it's going to do the same thing. So that's not a big problem. But if you get to that date.now call, then that's going to resolve down to a library call to actually get the current time from the computer. And that's where replay comes in again. And that's something that's going to be in the recording. The really nice thing is like print statements. All we have to do is replay, and then you can get those logs.
I feel like the amount of ways that JavaScript can be non-deterministic is increasing a lot. Like browsers are adding more and more functionality to interact with the system, whether it's getting a file from the system or accessing the camera or getting performance data or crash. Like there's more and more of these non-deterministic APIs. So are you having to like constantly stay on top of all the new ways to have non-determinism, or is there a way that you can kind of go one step lower and kind of capture all those without constantly adding new support for new features?
So these are the questions that browser engineers ask us. Like for instance, we were talking to the WebGL team at Chromium, and it just hurt their head. Because like you're thinking about like how complicated WebGL is, how complicated Canvas is, or how complicated DOM is, how complicated JavaScript is with all these APIs. And all of these components resolve down to like the same 400 library calls. In fact, like recording Firefox and Chromium is kind of the same thing when you're at that level. There's millions of lines of C++ to implement the browser, but we're not thinking about it at that level. We're thinking about it kind of at like the bottom of the ocean. What is the browser doing when it's actually talking to the computer? So yeah, there are tons of APIs, and there are some that we don't support right now. Like we don't support video, but when we do get around to video, it's going to probably get back to those same API calls.
So you kind of sit below at the deepest level of where the browser talks to the system and asks for system information, and by monitoring what's happening in that communication layer between the browser and the system, you don't even care what the communication is as long as you monitor it and then make sure the same thing happens in the replay that it did during the recording.
A similar question we get is, God, if you forked these 3 massive projects, the rebase must be hell. And the nice thing is because we're at the bottom of the ocean, like most of the commits just like flow right by and we never see them. I think like 1 out of 100 or 1 out of 1,000 commits have a conflict.
I'm curious how data intensive is a recording? Like if I record 5 minutes of me interacting with my web app, how much data does that capture?
So most of compute is deterministic. A React component, a React app is mostly just going through the same render loop time and time again. And that's kind of what React figured out. Like you give it the same props, you can get the same, UI. A very small percent of compute is non-deterministic, where you actually have to do like a date.now. So these replays are tiny, like 10, 20, 50 megabytes. But if you play through the recording and look at the entire execution trace, it's massive. It's like the joke for us is you can replay through a recording and make a video, but the video in terms of like megabytes is often bigger than the original replay.
Yeah, which is the same with LogRocket and our replay technique. It's like because we're just capturing the DOM and how the DOM changed over time. That's order of magnitude lighter weight than a MP4 video file.
That's a great analogy. Yeah.
And when you mentioned something at the beginning about like playing a replay faster than it occurred in real time, and is the correct way to think about that? Like the amount of time a real session took was like how quickly the user interacted with it. But if you play back those user interactions faster than they occurred in real time, the JavaScript code certainly executes very fast. And so you could replay way faster because you just like make the series of user inputs and non-deterministic API calls happen faster than they did.
So it'd be pretty cool if you could add a print statement and then see all those console logs in real time. But if you actually want to be debugging and you have to wait 2 minutes to get those logs back, that's not a fun experience. It's a cool toy, but it's not the kind of debugging environment you want to be in. So we have to be able to evaluate, maybe 100 expressions if the print statement was called 100 times in under, let's say, a second or half a second. So that's just another thing that we have to figure out to just go through the recording really, really quickly.
And I can actually give an example of where this comes into play. There's a new feature that we're, I think, ideally releasing in experimental today. So in replay, when you open up one of these recordings and you go to the DevTools debugger, and you pause the app and you open up one of the source files. As you move your mouse over any one of the lines in the standard DevTools debugger, as you hover over a line, it'll show you how many times that line got executed over the course of the recording. And that right there is useful because it starts to tell you, like, how many print statements are going to have, or like what lines were the hottest, or like, did this line of code actually run at all? Right now, in our production version, if you hover over one of those lines, you'll see a loading indicator for a couple seconds as it queries the back end for the information of how many times did this one line get hit. Well, one of our engineers, Josh, has been implementing some updates to both the back end and the UI to where as soon as you click on that source file and you bring up the contents of the source file in your debugger, it queries the back end for all the hit counts for every line in that file in one shot. And it can just calculate that real fast, bring back the entire hit count result in a second or two. The immediate benefit you're going to see as soon as this feature is out is now, as I move my mouse back and forth over those lines real fast, the little tooltip pops up immediately and says 1 hit, 5 hits, 1,000 hits. But this is actually going to unlock some very, very cool features. Like, what if we can highlight the lines that got executed or gray out the lines that never ran at all? What if we can start showing some heat maps showing which lines were the most computationally expensive? Like, I'm actually really, really excited about this feature, and I haven't even had a chance to try it yet.
Got it. So that's kind of like, because Chrome has a code coverage tool. So does this leverage Chrome's built-in code coverage, or you've rolled your own on top of the replay?
Oh, we've rolled our own.
Very cool. And I'm actually curious, like, on that note, I think Chrome has some kind of basic replay functionality. So, and I'm not even as familiar with what state of the art in Firefox or Safari. Like, do you leverage any of that functionality, or you've kind of built everything from scratch? And it sounds like replay does quite a bit more than those kind of basic tools, but just curious to.
Yeah, you could think of Chrome's replay as browser automation. It's using Puppeteer under the hood. It could be using Playwright. It could be using Cypress. And their definition of replay is you record some user actions, like I'm going to click and type. And then when I click the button, the browser is going to redo those actions again and again, which is really nice for getting in a tight feedback loop as you're developing or testing a feature. But it's not the same thing as being able to share a replay with a developer and then seeing exactly as it ran because we've recorded it.
Right. And if the approach is simply just to replay the user actions, any other source of non-determinism, be it a call at a date.now or an API call, or it's not going to be deterministic. The replay could be different than what you originally did. Yeah.
if I'm recording, I don't know, going into an admin panel and deleting a user, well, that automation is because like there's no more user to delete. But in replay, I can view that time and time again.
Awesome. Well, I think now would be a good time to jump into the demo. So as I mentioned before, we're going to have this on our YouTube. We'll try to describe what we're seeing, I guess, for the audio folks. But should we jump in?
So right before I jumped on this call, I was thinking about this bug that I saw in LogRocket 6 months ago when I was trying to filter the Redux actions and find something that was going wrong. And at the time, when I would click on this timestamp that you can see right here, and I'd been filtering, the timestamp wouldn't jump to that spot. So we do this thing pretty often where when we see an issue, we record it with replay and we see if we can figure it out. And if we can figure it out, we send the replay to somebody on the other side. So we've recorded issues in GitHub, in Facebook, in Asana. And when I saw this issue, I sent it over to Matt, who's the CEO of LogRocket, and honestly has been one of the people who I've reached out to when I've had questions, which is amazing. If you start a DevTools company, I strongly recommend finding other founders who can help you along the way. And Matt's been one of them for me. And I was really excited to share this replay with him. So right before I jumped on this call, I remembered that it was possible to record LogRocket and see what's going on. So I thought like, hey, what if we record something we can look at it and replay together? So this is the replay I just recorded 5 minutes ago. You can see that I was doing something similar where I was looking at the Redux actions in LogRocket because LogRocket uses React and Redux, and I was clicking on that timestamp. And you can even see over here in the viewer, we capture the click events, navigation, so we can see what's going on too. The reason we offer this viewer, which is really similar to like a session replay tool or a video tool, is even though we're in a time travel debugger, it's nice to describe what's going on. So I want to be able to click, leave a comment, and say, hey, that's interesting. You should look at that too. But the really interesting thing about a replay is being able to switch over to DevTools and see what's going on. So when we're in replay DevTools, the goal is to be able to do anything you can do in browser DevTools. So of course, we have the console so we can see what LogRocket logged out in production or logged out in that replay. You can rewind, fast forward, those kinds of things. If I play back to the middle, I can go to the Elements panel. We can see any of these components, its attributes, those kinds of things. And we could do the same thing with React too. So I can see there's this component for the network monitor that had all these props. But what I really want to do, because I knew I was jumping on the call with Mark, was find the Redux calls, those actions that are being dispatched to set up LogRocket. And I think I found that. So I'm going to hide the video here, make this a little bit bigger, go back to the comment, and this should be recognizable. I think what this is Redux's setup code that's called every time a thunk is dispatched.
That looks like the thunk middleware to me.
And just to maybe explain this to the audience, so we're looking here at LogRocket's minified production code, because Jason doesn't have access to our source code, but when you use LogRocket, you obviously could see our minified production code, and just based on your experience, probably looking at a lot of minified code, you were able to figure out this looks like where Redux middlewares are being initialized. And
what I did was I used our search tool to search for all the calls to dispatch. And then from there, I found one call to dispatch, stepped in, and that took me into the middleware. And the reason I wanted to be in the middleware is I wanted to see all the the dispatches to get a sense of what's happening within LogRocket.
Got it. And I imagine most of the time when people are using replay, they are using it on a development or staging build of their site where the code would not be minified. It would probably be a lot easier to know what you're looking at, right?
And we've got source maps.
Oh, and you have source maps, even better.
So the story could be support, QA, even a user in many cases records the issue. And because, let's say we were working with LogRocket, let's say you'd set up a replay internally. If somebody in support records an issue on LogRocket, then when the developer is looking at it, they can see the replay with source maps because you've uploaded the source maps to replay as well. So it's kind of a Sentry use case as well.
Got it. Makes sense.
And I can give a personal example of an actual bug that I fixed for Redux stuff with Replay a few weeks ago. So I was working on the release of Redux Toolkit 1.8, and we were releasing a new feature called a listener middleware, which has some similarity to like the Redux Saga or Redux Observable middleware that let you run logic in response to dispatched actions. And we'd had that in alpha and beta for a few months, and I was literally getting ready to actually release, RTK 1.8. And all of our tests had been passing the whole time, and I wanted to just do a quick check against kind of like some kind of an actual application before I hit the button and push this code out. And boy, it's a good thing I did. So I did a local publish of the RTK library, created an example app, and actually copy pasted one of the examples out of our code base. And I installed the local build of RTK into that project. And it was just a basic counter example, and I went to click the increment button and nothing happened. And I kept clicking and nothing was happening. It's like, wait a minute, this is not good. And I opened up the normal browser DevTools and was trying to stick some breakpoints in there. And there was a loop where it was like the action has been processed by the reducers. Now we want to loop over all the listener entries and see if any of them are actually supposed to process and handle this action and run more logic. And for some reason, it was basically stepping over that loop every time. Really confusing. So I went and I recorded a replay of this, and I actually pulled Jason in on it because I was able to send him the link for the same replay. And we're going through it, and again, like I was looking at the source mapped view of the code, and it was a for of loop that was looping over the values in a JavaScript map object where we keep the listener entries. And I could see it skipping right past the loop. And I was able to switch over to the non-source mapped view and look at the transpile code that was actually running and see that there was actually a bug in the compilation step itself that was causing a bad loop to be emitted. And I remembered that I'd actually seen this same issue a year ago on a previous RTK release. There's something about our library build setup, the combination of ES build and TypeScript, that occasionally spits out weird code if you're doing for of over a map or a set. And so I was able to identify that, and then the workaround was convert the values into an array first and then loop over the array. But I honestly would have been very, very stuck on trying to do that release if I hadn't been able to step into the replay, identify exactly what was going on, and flip back and forth between the transpiled code and the source map code. So even that right there was really valuable for me.
Awesome. Yeah. Very cool.
So we just added this print statement into the thunks, and I'm looking at the console, and I can see we have this called identify user, so we can see who's logged in. It's kind of fun to see what the data retention policies are. So we have data retention in general of 1 month, but then the set search data retention is also a month too. So you can see there's some granularity there, the active apps there. Oh, this is fun. It looks like the feature flags are also being logged as well. So feel free to redact this section. But the ability to do conditional recording, in-app demos, live mode, that's kind of fun. I wonder what live mode is. Impact? Are there any in here? SSO is false, so that's not been feature flagged on. RBAC is here, pro beta access. I don't know. I mean, this is stuff that is being shipped, right? Like I could see this in Chrome DevTools if I opened up the debugger and I was looking for these kinds of things. But it's just funny to me how in replay, the ability to just jump around, you find these things that are shipped all the time that it's just interesting.
I'm curious, like, is in the future, or is this something either today or in the future, is there a world in which during a replay you could change something? Like, let's say I don't know if there's a use case necessarily for like changing. Well, there probably is for like a Redux action, or something as simple as like change what a variable is in a replay, and just change that, and it may or may not break the app on replay, but yeah.
Yes, the short answer is yes. So the simple thing that we've already shipped is the ability to pause at point in time, go into the console, and do something that changes the DOM. So I can find an element and change its background color. The thing we would like to do, let's say in the summer, is open the elements panel, click on an element, and edit its styles like directly in the elements panel. You can imagine as a designer, you can see a button that looks bad at a certain point in time, fix the styles, share it with the developer and say, hey, it should really look like this. But that question about changing a value or changing a variable and then seeing what it looks like, that's actually kind of profound. The ability to record 1,000,000 replays of React, see the common issues, and then begin trying to fix them. That stuff has only been possible in video games before now. So the way OpenAI got good, like in the early days when they want to play like simple video games, is they got their hands on a couple million recordings of Dota 2, the video game. And they were able to put that into the AI system and then have the AI try to win the game, because some of these games the player had won, some of the games the player had lost, and the AI was able to go to an arbitrary point in time and say, well, what if we did something different? What if we try a different strategy? And that was how AI got good at video games. We think there's a similar story for debugging software, where if you can get 1,000,000 recordings of React, and sometimes there are bugs in there, we can let the computer begin trying different strategies. What if you modify this if statement, or if you change this Redux thunk, or you add this hook here? Does that fix the problem? And that's the interesting thing 5-10 years out for replay. Not necessarily building the time travel debugger for people. That's great. That makes software more approachable. But the data that comes from replay, when you can do dynamic analysis after the fact, and when you can actually like arbitrarily debug after the fact as well at scale.
Yeah, and I'm even like thinking, replay my app and change the payload of a network request or a response that came in, or things like that like just in the normal development workflow would save so much time. And a lot of times it's just like hard to get your app in the state you want it to be in. And if you could, in the replay, just do that would make things way easier.
Totally. And a simple one that I've been thinking about recently is intermittent tests. You write the test, it passes 95% of the time, but then like 5% of the time, something happens that's like too fast or too slow, and you're not sure why. And those are the most difficult things to debug. But if we have 1,000 recordings of that test, and let's say like 100 failed and 900 passed, we can look and see, oh, those failing tests, the API call came back too fast. And we could even try to simulate that API call taking a little bit longer and see if the test passes. Because we work at that low level, we can simulate like a socket connecting and then the packet coming a little bit slower, and then replay with that slightly modified recording. And if that turns out to fix the test, we can tell the developer like, hey, maybe you want to add a wait here, because that's what's causing the flakiness.
Yeah, no, I mean, that makes a lot of sense. And I'm curious, you mentioned before the concept of like having thousands or millions of replays and doing interesting things with that data. One of them is, it's, if you have as you just mentioned, you have a flaky test, how do you identify what are the outliers or what things are different the times when the test fails? What are other, maybe in the future ideas in terms of like more concretely, like using large amounts of replays to get insights?
Oh, God. And by the way, the biggest caveat here is we treat privacy incredibly seriously. So replays are private by default. Enterprises who come on, they own their own data. So with all of those caveats aside, the ability to look at a corpus of React recordings is incredibly useful for the React team. It's also incredibly useful for the VA team that wants to see where's the job search engine fast, slow, etc. I can go on and on. The idea of replay as data is really, really powerful. Like I could be in my text editor, hover on a variable, and in addition to seeing the TypeScript values, I can also see some example values that came from recent replays. And maybe that function was called 100 times and only once it received like a false Boolean, like every other time it received true. I could click in and be at that replay at that point in time when it received the false and get a much better idea of what's going on.
Yeah, no, super interesting. And one question I actually had, which I should have clarified this earlier, what is the format of replay? Like we're looking at here is a app.replay.io. We're in a web browser, but it sounds like where you actually record the replay session is in a forked version of Chrome or Firefox, so like a native application. So is that primarily how it works? Like you record in the native application, you replay in the browser, or?
We primarily record in the native app. So it doesn't matter if you're recording a Jest tested node or an Express server node, or you're recording LogRocket in Chrome. You click record or you run, replay node, you make the recording. The recording itself is this like array of binary blobs. it literally is like the system call inputs and outputs. So not very human readable. We then upload the recording to the cloud. We, when you want to view the replay, spin up a Docker container, download the runtime that was used, download the recording, and then run through it. The funny thing is like that recording might be 10 megabytes, 20 megabytes. When we're replaying, obviously there's a lot more going on. And then when you're actually viewing the replay, the replay dev tools is a React app. It's a Redux app. It's just talking over a WebSocket to that backend.
And that's kind of where I came in. So I joined the team 2 weeks ago, and I'd actually the replay client code base is actually entirely open source, and so I'd actually had a chance to go poke around it as I was talking to the replay team about joining initially, and it's a large code base. A lot of it originally started as a fork of the Firefox dev tools, but it really is a large React Redux application. And so as I've been coming in, I've been poking around, learning how things are put together, doing a lot of code cleanup. There's code that's dead. There's code that's using some older style patterns. But even though I don't necessarily understand all the ins and outs of the code base right now, I've been able to jump in and start doing cleanup, modernizing some of the code base. And I mean, it's just a React Redux app. I know how those work.
To plug Mark for a second, if anybody listening to the podcast now wants to work with Mark, come join and help us. We are taking this legacy Redux app that's all JavaScript, converting it to TypeScript, converting it to RTK. RTK landed last week. Every reducer is being updated. It's a really fun time to get involved.
Yeah, I've been having a blast getting to do some of the modernization. And also, at the same time, I mean, it's a live code base. There's people on the team working on new features right now. I'll move on to some feature stuff down the road. In fact, actually, Jason and I were just talking. Like, there's right now we've got the React dev tools integrated directly into the UI of Replay. Like not the extension, but actually as a component in the page, and it listens for basically the React specific data coming out of the app. And we plan to actually have me do the same thing for the Redux dev tools, probably this next quarter. But there's nothing that says we can't do the same thing for like the Vue dev tools, whatever Angular has. This is a starting point, not the finish line.
Yeah, and I imagine it'd be cool to get. I don't know. I imagine you have some kind of network request inspector, but like you could bring in like something more like Postman or like a more advanced
Postman, Apollo, Relay, anything GraphQL related, it can all be there. If you want to understand your Algolia queries, you can format those as well.
Yeah, a lot of cool possibilities. And on that note, can you preview kind of some of the other big picture items that are on the roadmap in the next year or so?
Oof. Year is tough. We could talk Q2. So Mark mentioned Redux DevTools. There are going to be some really fun React DevTools features that we're going to ship this quarter. So something that I think about is if you pause on a React render function, the call stack is meaningless. Like you've got your render function, and then every other frame is just React internals. But what you want to see is I'm paused in this button component, and the button component is in a list component. The list component's in the header, and the header's in the app. And we're calling that the React component stack. It'll be like a call stack, but it's going to work with just pure React. So you click on one of the other components, and then you're up in that component's render function itself. You can see all of its props, its state, everything. Another thing that's coming in Q2 is CI support. So last week we we shipped first class support for Playwright, Playwright and Playwright Test, but we're going to add Cypress support. So that's a prototype now that you can begin using in alpha version. That's going to be first class. Puppeteer, Storybook, Selenium, anything that you use for automation, you should be able to record as well. And then when a test fails in CI, you just have that GitHub comment and you click it and you can be in the replay.
And I'm curious to learn a bit more about the business side. So, I think Mark mentioned earlier that replays the replay side is open source. Is the recording side open source, or is that still closed source for that native application?
So our forks of Firefox, Chromium, and Node are open source. The driver that we use to record is documented. We would love to work with more runtime folks, like the Python community, the Ruby community, to begin supporting other runtimes as well. The goal is for runtimes to be replayable, and the more that we can do to make that first class, the better. On the backend side, the protocol that we use for DevTools is also documented for a couple of reasons. But the one that I'm most excited about is we're doing the simple version of DevTools. Like it's a joke that we shipped with print statements. It's like taking a rocket ship and putting it into a car and like talking about how much faster you can go. You could take the rocket ship to Mars. And the DevTools protocol that we shipped, I'm so excited to see how people are beginning to use it and where that can go. Because people are going to build way more exciting things than print statements. Like we had to do that because that's where devs are now. That's how people debug now. But if you think about the future of debugging, it's really, really exciting.
And you charge a monthly fee based on one developer license, and that's basically is getting you access to the cloud platform, the ability to share. Is that accurate? Yeah.
The way we think about pricing, we charge $75 per dev for the organization plan and $20 per dev for the team plan. And I mean, the team plan's nothing, but even on the organization side, if you have one bug a month that is helpful, it's paid for itself.
I mean, think about how expensive developer time is. And if you save yourself like an hour or two debugging something, it literally just paid for itself.
And we have users who spend hours a day in replay, much less an hour a month.
Yeah. And I mean, a lot of times our customers justify LogRocket a similar way in terms of developer time spent. But then if you can fix a production bug more quickly, that could save you untold amounts of money if it's an important production system.
Yeah. Mean time to resolution obviously is huge.
And the flip side is it is free for individuals, including the open source community. As a Redux maintainer, my standard refrain anytime someone files an issue is, please provide me with a GitHub repo or a code sandbox that reproduces the issue. And I want to start making like asking for a replay a standard part of that. And honestly, like part of our goal is like that would become a standard thing for the open source community. Like, think about how much faster so many bugs could be solved if the user was able to provide a replay, as part of the issue, and the maintainer could just step in and go see exactly what happened and not even have to reproduce the problem themselves.
It's incredible for open source maintainers because it's even more difficult to reproduce bugs in the open source than it is within a company. And then, because at least at the company, you have the code. But then you go one level up. I've talked to so many people who started programming and then dropped out to do other things because they loved building, but debugging was hard. So if we can make everything from like that first hello world function that you write easier to understand, our hope is that more people will start programming, stay programming, and really love it.
Well, Jason, Mark, it's been great having you on and really exciting to learn about replay. It sounds like you are hiring. Is that correct?
Yes. If you're interested in any aspect of replay, from the browser side to the backend where we run thousands of Docker containers to the dev tools where you can work with Mark, let us know.
And for folks who want to learn more, check it out and get started. It's just replay.io.
That's right.
Well, thanks again.
Thank you.
Thanks. Appreciate it.